So just wanted to take a wee minute to talk about single step and remind us what single step does. Just to, that it's about the single steps referring to the fact that we're combining the pedigree, the phenotypes and the genotypes all together in one single step into the evaluation to generate the breeding values. So instead of doing a mix and match and then blend later, it's blended in one single step. We know there are benefits. We've increased the accuracy of the breeding values. The value spreads across close relatives of genotyped animals. We get improved predictions, particularly in the young animals, which we really are caring about. And we're getting a better comparison between the genotyped and non-genotyped animals. So cool stuff. But the accuracy, like reporting the accuracy, has been a bit of a problem. So that there's nowhere globally that has got an acceptable math to be able to report accuracy, or to a level that we're satisfied with anyway, for the extra accuracy it's bringing. So we've chosen to do the reporting conservatively as pedigree accuracy alone. So we know it's doing better, but we're giving you a conservative accuracy prediction from that. But that makes it hard to figure out the value of the genetics. I want to remind you that it's for the maternal breeds only. It's for the Romney, Coopworth, Perrindale and composites. That health traits, generally the reporting is restricted to those recording the trait. There's a few occasions where those rules can, it's legitimate to open that up for when it's an accurate genomic prediction, but generally it's restricted to those recording the trait. And the breeding value based on just doing the genotype alone is a yet to come. It's a work on that we're still doing. It's not yet for terminal breeds. So there are genomically enhanced breeding values that are provided through this SIGC, so the South Island Genomic Calibration site. So there'll be some participants at that site in the room. So you're getting genomic breeding values for meat quality traits. They're not coming for maternal or for terminal worth traits, but we know this is still a work in progress. We want to be able to spread this out. And one of the questions we're still hanging up on is, will we be doing a single step that's maternal and terminal together in one single step? Or will we have a maternal single step and a terminal single step separately? So this is a work on, it's part of what Michael's got in front of him to be solving over the next wee while. Recommendations around genotyping. So we still are recommending using a mid to high density chip, so 50K or 600K, good for the size that you're using, the ones that you're using in your own flock. That all progeny that are going to be candidates, or candidate replacements, using a low density chip. I think it's actually supposed to be more like 15K, sorry, I didn't fix that anomaly there. But it doesn't have to be all progeny, and there are some cases still for parentage only, if that fits for you. But what about the value? So Michael's come up with this idea of doing a scenario approach. So we just come up with a scenario, or what we thought might be a typical situation. So thinking about your stud flock having around 1,000 ewes mated, that you're using 16 rams, with 12 of them being young and 4 being older, so you're getting the year-on-year connectedness or getting more progeny from a really good ram. And so it's pretty a high ratio, but just to see, this is what we put into the scenario. Looking at 140% weaning to ewes mated, so getting 700 ram progeny out, and 12 of those being retained, so they're becoming those 12 young ones. So you're replacing 75% of your ram team annually, and thinking it's equating to around 2% selection pressure from the ones that are weaned. Of the ones that of the rest of that ram group, that you're selling 200, so around 30% of the rams sold for those that are weaned, and having a 30% replacement on your ewes. So just that first question, does this sound like a typical scenario? It won't be everybody. Somebody will have a little bit more, a little bit less and such, but is a fair typical starting point? What do you think? Is there nodding? Lots of nods? Okay, thank you. So this is exactly the same information, but in a graphic for if you're not a table person like me, and maybe you like pictures of sheep better. So it's the same information, about 1,000 ewes. This is that replacement, 30% replacement. You're getting your 12 new rams from this group here, and having the other ones sold. So they're your candidates you might be testing. Today we're going to describe the benefit of genomics over the pedigree alone, and it's based on the New Zealand maternal worth. It has been calculated for DAG and facial eczema, worm, feck and meat, but today Just going to focus on the maternal worth value. The benefits we're describing are for your RAM buyers. Okay, so for those that are actually coming to purchase your RAMs. With considering 1 test year, and it's calculating the benefits over 10 years with a 6% discount per year because $1 today is not exactly the same as $1 promised tomorrow. We're assuming a cost of $30 per RAM genotype from those candidate RAMs. And if you're doing DNA parentage already, then it's an $8 extra cost to get that genomic. Okay? Just you're thinking about the benefit you're going to get from genotyping your tutus. So you can be doing almost all of them, down to a few. Now if you have a look at the value that you're going to get from that. So on this scenario, doing more animals, so close to all of the ones that were weaned, you're getting $114,000 benefit over those 10 years, or your RAM buyers are. It's going to cost you more. And so the return on, it's going to cost you as a breeder, I suppose, more. And so this return on investment is your investment and the return that your clients are going to be getting. You can test fewer and have less benefit, but it's cost you less, so the return on investment's getting a wee bit higher. And I'm not here to tell you which is the right thing for you. It's about your appetite for what your spend and the cost benefit for you and your clients would be. Yeah. So it changes if you go younger. Okay. Just comparing it with the DNA parentage cost, so just thinking about the extra you've got to do to be able to go from parentage to genomic. So it's costing you an extra $5,000 to do all of the, or pretty much all of the animals. So your return on investments here, and then you could do fewer of those animals with the extra cost, not being quite so expensive and getting a higher rate of return on investment, but it's it's about for you to really think you fit for what you want to be doing. I'm going to move to the next slide so I can have some text, but if I want to come back to the slide, we can. I was just putting that in the graphic and thinking about perhaps there's a sweet spot in just doing these candidate replacements here, and I've got the next comment's going to be based on that rather than doing the full 600. So just to summarise that table, more tests is more benefit, but reduced return on investment. It's definitely the benefit for your RAM buyer, not just you, so whether or not you can sell those RAMs for more money to that buyer. The RAM breeder merit is typically, so if we're thinking about doing those candidate replacements around that 212 RAMs that are either going to be sold or used for yourself, you can be increasing your merit by about 21 cents per year on maternal worth, and it's equating to about a 10 to 15% increase on genetic gain. So how does that sound? Going twice as fast? Yes, okay, I'll repeat the question for you. But so you were saying that some years ago, Zoetis were talking about those that are doing genomics will be going twice as fast or doing 50% faster genetic gain than those not doing it. I think the difference there will, and actually might voice up and tell me, but I think the difference will be there. We're talking about one test in 1 year, not continued testing. So if you keep continuing testing, these values are going to increase. And whether or not Michael wants to make a comment there, would be great. You're welcome.
Yeah, no, it depends very much on the scenario because I picked one scenario here, and it's basically a test of the ram lambs at 2 tooths and that, but there's 100 different selections you can choose, and I don't know what the assumptions that were used in that value proposition, but there's no one value proposition we can do for this. So it depends a lot on the assumptions and when you're going to test your rams and at what age, etc.
Yep. So it might also be thinking about younger rams. Yep. So if you're testing every year, Michael?
So generally it's cumulative. So I think in the scenario that I've given, where Annie's got the pictures of the actual animals, so basically testing about 20% of those 212 two-tooths, okay? The year-on gain for your ewe flock is, we calculated to be about 21 cents per year, and that's about a 10 to 15% increase in the rate of genetic gain for a typical flock.
And talking about maternal birth traits, I mean, what does it change?
NZGE for New Zealand maternal work. Yeah, so it's a modest increase, but I mean, if you look at it, you're investing probably under $2,000 to basically increase your genetic gain by about 15 or so %. So in my mind, it's a modest investment without much work to get a increase in your genetic gain of about 15%.
Any other questions on that? Cool. Anything from online? No? Cool. Well, thank you. We'll move on. The next topic then will be moving into our the connectedness, Sharon, I think. Oh, hang on. Breeding on genotype alone. That's right. I'm going to hand over to David on this one. It's been a wee part of his area. There you go, Dave. Thank you.
Yeah, I think so. Look, we won't dive into this too deeply. It was more just to make sure that you're aware that the topic's on the horizon. We'll definitely send some communications out to ask for your feedback. But in short, in the old multi-step system, it had some drawbacks, and that we had to calculate the breeding value of the recorded phenotype separate to the breeding value from the genotypes, and then combine that or blend those together, and making sure that we didn't introduce bias. I mean, for Michael and the science team, it was quite a complex process to manage and keep it up to date. And the obvious advantage moving forward with single step is now all of that is done in a single step. One of the byproducts, though, of that old multi-step system was that breeding value that was just calculated from the genotype. And so we no longer have that available to us in the current single-step system. And so really, we've had a number of parties approach us that used to be able to use that standalone genome MBV that was based off the genotype, and have basically asked, is there something else similar to that we could have? And so we're just going through the process at the moment of consulting. We need to sit down with the labs and understand how it was being used in the past and collect their feedback. But we've had other interested parties approach us as well. And so we just, in the roadshow, really just wanted to flag that topic's on the horizon. And I guess just while we had a room full of breeders, was really just polled to see if anyone in the room, any breeders in the room, were using those standalone MBVs previously, and a feeling that the loss of them now that we've moved into single step. Do any of you have any commercial farmers that may have been using those within flock or anything like that? Okay, cool. No, that's fine. Look, we'll go about collecting the input from industry, and we will circulate what feedback we've received, and whether there's any potential new tool that we can put in the breeder toolbox as well. That was great. Thank you.